Okay, good morning, good afternoon, good evening, everyone. This is Frederick Winsness with NetHope and the NetHope Solutions Center. I want to welcome everyone to yet another NetHope Solutions Center and the No Loss Generation Tech Task Force webinar. Today we're going to talk about Introduction to AI and Artificial Intelligence for Good. And we are very, very pleased to have USAID represented here, and we'll get to the speakers in a couple of minutes. Before we get started, just want to go over some housekeeping rules. We do want to make this as interactive as possible, so please open up the chat window in WebEx. You do that from the third from the right icons on the bottom of your screen under the slide here. And there you can observe chatter between the speakers and the audience, and particularly post your questions there. So we will have a Q&A session towards the end of the hour today. We are recording this today, so please look for an email with a link to the Solution Center posting of this webinar. There you'll see the recording and the collateral that's being covered here today. And at the end of the session today, in your browser, you'll see a webinar satisfaction poll. We certainly would appreciate you answering those few questions so we can help improving this webinar series over time. And with that, I'm going to introduce Leila Toplik. She is with the No Loss Generation Tech Task Force effort here at NetHope. So pass it over to you, Leila.
Thank you, Frederick. Good morning and good afternoon, and welcome to the webinar on AI and AI for Good. In fact, per popular demand from all of you from our NetHope community today, we'll be talking about artificial intelligence, or AI, and machine learning, and how these tools, in fact, can help us do our work better. So whether it's understanding the problems we are facing better, making better decisions, acting faster in urgent situations like disasters, or meeting the needs of more people. So clearly this is a big topic that can be covered in just one webinar. So before we get to today's presentation, I want to frame what we have planned for you in terms of the engagement around AI for Good topic. So based on your inputs from the NetHope membership and partners, this initial engagement around AI for Good topic, which is inclusive of this webinar and also our NetHope Summit sessions, is really designed to do a couple of things. One is to provide all of us, NetHope community, with information about how artificial intelligence and machine learning tools can benefit our collective work. Second, really facilitate sharing and discussions within our sector and cross-sector with technology companies and academic institutions. And then third, inspire, hopefully, future projects and collaborations. And clearly, this is the first step in a process which will provide a foundation for future training, for future sharing, for future collaborations. So with that in mind, we've curated 4 sessions, each different format, and also designed to be additive in terms of knowledge shared and discussions that we'll have. We have, as you can see from this slide, we have a stellar lineup of humanitarians, technologists, and researchers, and we'll cover a range of topics. And on that note, the title AI for Good can be a little bit misleading, implying tech centricity. And while technology like AI is an incredibly powerful tool, it never should be the starting point for doing good. So we'll spend most of our time really sharing and discussing what do we need to do better, what problems do we need to solve, and that's where AI and machine learning, along with other tools, can help us do that. So just going to the next slide to give you a snapshot of the discussions that we have planned for the summit, but also to really emphasize the importance of this ongoing two-way communication with all of you in the NetHope community to help us share future engagement. In fact, you can help us shape future engagement today by completing this survey and sharing with us what you'd like to hear more about, what you might want to share with our community. So here are some of the questions that we'll begin answering today, and we'll get through as much as possible. Do note that you should be sharing as many questions and also examples in the chat window, and we'll get to as many as possible in this conversation or continue the discussion at the summit. So we'll start first by building a baseline understanding of the technology tools of AI, machine learning, big data. And the reason why we're starting with technology and not the problems we need to solve is based on your feedback around there being more confusion than understanding or knowledge of these concepts, what they are, how they're different, how they're complementary. So we'll start there. But very quickly, we'll dive into what problems can artificial intelligence and machine learning help us solve today. And we'll differentiate between the things that are working relatively well and can be used versus things that are still in development and require more heavy lifting. In addition to talking about the opportunities, we'll also cover necessary conditions for some of these AI-powered solutions to benefit our work, as well as some of the key challenges and risks. And you've also asked for examples of how AI is being used in our sector today. So Craig will first share a set of possible problems that AI is capable of solving today, and then provide some of the early examples of applied AI in our sector. But there's so many more examples which you're involved in or aware of, and we're looking forward to hearing about those through the survey. And then lastly, we'll also talk about what we in our sector need to do today, including how we can influence the development and use of AI. So quite a bit to cover, and it's my pleasure to introduce to you Craig Joly, Senior Data Scientist at USAID. Craig is also the co-author of a recent report on AI in international development, and we'll share the link for you in the chat window. Over to you, Craig.
Hi, thanks so much, Leila. So there's my slides. I don't think I'm going to be able to advance them myself, so can we move on to the next slide? Okay, great. So as Leila mentioned, these are going to be the major things on our agenda today. I'm going to talk a little bit about these terms of artificial intelligence, machine learning, and big data, and help to put those and their relationship to each other in a little bit of context. We're going to talk about what AI can do today and the things that are happening right now, some benefits of using AI, as well as some examples of how it's being used in my sector, the development sector in particular. We're going to spend a little bit of time on challenges and risks, and then what we all in this community can do to help shape the trajectory of AI going forward. Next slide, please, and we can just go to the next one. All right, so this is a timeline that Leila actually shared with me a little while ago, and I really like it because it shows some important moments in the early history of AI. And I'm not going to read the whole thing to you, but I do want to emphasize two really key things. One is that the concept of artificial intelligence has been with us for a while. Almost as soon as people started programming computers in the 1950s, they started wondering whether it might be possible to recreate true intelligence in a machine. The second point is that since the very beginning of AI, we've had some very smart people who've been much too optimistic about how quickly the field would reach some important milestones. And it turns out that intelligence is really, really hard. It's harder than anybody imagined. And this is especially true for the kind of human-like intelligence that AI researchers refer to as general intelligence. And so the safe bet is that this trend is going to continue, and going forward, we'll see some very smart people making predictions that turn out to be overly optimistic. Next slide, please. So this list that you see here takes that timeline from the last slide and brings it up to the present. And to me, there are two really big things that jump out. One is that there's been a lot of progress in the last 10 years or so, and a lot of that has been enabled by new hardware and software models. So talking about things like the usage of GPUs to train neural networks, or open source tools like scikit-learn or TensorFlow that have really expanded the pool of people who can apply machine learning and AI. And I think those open source tools are really one of the things that are shaping the field's evolution at this point. The second thing that we're seeing is the emergence of consumer products that incorporate AI. So on this list, I've mentioned Apple and Amazon, but I could have mentioned many, many more. And this is also a really new phenomenon, that people have AI-enabled tools in their homes. And this is going to dramatically change the way that people interact with computers going forward. Next slide, please. So now that we've talked a bit about the history of AI, I want to explain a little about what machine learning and AI are. You may have seen other definitions, and I'll show you some more nuanced ones in a minute, but for now I want to start simple. And at the simplest level, all machine learning and AI systems are built on data. And data can come in a variety of forms, including images, text, audio, and numeric data. Next slide, please. So the next layer here then is machine learning. So what machine learning algorithms do is they search for patterns in large data sets, and they use these patterns to make predictions about what might happen with new data. And so as a shorthand, you can think of machine learning as data-driven predictions. Next slide, please. Artificial intelligence systems then use these data-driven predictions to make, do, or plan something. So for example, an AI system might make an image or a passage of text. It might do something by controlling a robotic arm, or it might plan a driving route from one place to another. And sometimes AI systems will act directly based on these automated decisions. One example of that would be robotics. In other cases, AI systems will make suggestions to a human decision maker, such as with product recommendations and online shopping. And so for shorthand, you can think of AI as being smart automation. Next slide, please. So here are these more nuanced definitions I promised you. So I often see AI defined as the science and technology of building intelligent machines. And one difficulty with this definition is that we don't have a good definition of intelligence. It's a really hard thing to grasp, but in general, we think of it as involving things like learning, attention, memory, creativity, and autonomy. So at this point, the best way to think of AI is as a field of study like mathematics or chemistry, and not as a specific technology. Machine learning, then, we can think of as a subfield of AI that's specifically concerned with learning. So AI was there long before machine learning was. AI started up in the 1950s or so. Machine learning is something that's really, it's been talked about since about the 1980s and has become a lot more prominent recently. And the goal in machine learning is to use computers to detect patterns in data and use those patterns to make inferences about unseen data. And most modern AI applications rely on machine learning, but as I mentioned, this hasn't always been true in the past, and it may not always be true in the future. The last term I wanted to introduce is big data. And big data is a set of technologies that have been developed to handle data sources that are big in terms of volume, velocity, or variety. And when we use the term big data, we're generally emphasizing data management above things like learning or predictions, although it's worth pointing out that 5 years ago, everyone was talking about big data, and now everyone is talking about AI. And if you look more closely, the people and the organizations and the companies that are AI things now were big data things 5 years ago. And so there's a lot of overlap in terminology, and some of this is just rebranding of old terms. Can we go to the next slide? Okay, so now I want to talk a bit about what AI can do today. Next slide, please. So this is a satellite photo of a neighborhood in Jakarta, Indonesia. And to explain a little bit about how machine learning works, I want you to imagine that your organization is for some reason interested in where there are cars in Jakarta. Maybe you're interested in congestion or traffic accidents, or you want to make some kind of map of the distribution of wealth within the city. At any rate, you have hundreds or thousands of images like this one, and you're interested in where all of the cars are. So how are you going to go about counting them? Can we advance the slide? Okay, the first option is to just count them. You could print this out. You could sit there with a yellow Sharpie and circle all of the cars, and before long you'll completely lose your mind and you'll never finish. Next option, get someone else to count them for you. We really like interns. Some organizations really like volunteers. This is kind of cruel, and it's a horrible thing to make human beings do. Next option, please. Okay, you could get a computer to count them for you. So now we're getting to something feasible. Next option, please. Okay, so for those of us who learned to program some time ago, this is the way we learned how to do things. You come up with a set of rules. So you sit down and you think about what you know about cars. Cars are sort of rectangular. They have a windshield at the front. They tend to be sitting on a dark background. They line up in lanes with other cars. And you come up with a set of rules that translates that into things that a computer can be looking for in the data. So this can work. Sometimes the downside is that it's an awful lot of work, and you have to spend a lot of time fine-tuning these rules to make sure that they're exactly right. Can we get the next slide? So this last one is the machine learning approach. What you do is you first have to go and count some cars. You need a certain training set of where you have known locations of cars. And based on those and the satellite imagery, you let the computer compare those two things and infer its own rules. And you can then go and apply those new rules to as much future imagery as you'd like to. Next slide, please. So what we're seeing here is another maybe simpler way of illustrating the difference between this traditional approach and machine learning. So in that traditional approach, you start by coming up with rules. And getting the right rules depends on your creativity and on your subject matter knowledge. And you can then apply those rules to imagery and you'll end up with car locations. In the machine learning approach, you start with two different kinds of data. You have imagery, and you also have some known locations. And a computer is going to take those two data sets as input and generate a set of rules for finding more car locations. You can then take those rules and apply them to as much new imagery as you'd like to. Next slide, please. So this is the same idea, but now we're going to put it in somewhat more general terms. In the traditional approach, you start with a model that's based on your own knowledge and you apply it to data to get an output. In machine learning, you start with input data and some known outputs. And with those two things together, you can get a model that comes from data instead of from your own knowledge and insight. Next slide, please. So one of the things I wanted to chat about a little bit is what machine learning does best. And before getting into concrete examples, I want to give just some sort of high-level abstract principles for the kinds of things that machine learning is good at. And the first one is things that don't require too much common sense or background knowledge. And my favorite example of this is when a computer was trained to play the classic Pong computer game. And for those who aren't familiar with it, Pong is a game that's designed to be kind of like table tennis, where two players will move a paddle back and forth and use it to send a ball bouncing to the other side. And this AI system could play pretty well. It could beat human players pretty reliably. But when researchers then went and changed the color of the ball or shortened the distance between the two players by a few pixels, humans hardly noticed. Humans could adapt to this without any trouble, and the computer just failed spectacularly. It couldn't cope with these changes. And the reason is that the computer doesn't have a concept of balls or paddles or walls or bouncing. The only thing the computer knows, to the extent that it can be said to know things, is that given a certain arrangement of pixels, its chances of winning are higher if it moves its paddle in a certain way. And adapting to changes in the game requires an intuitive grasp of physics, and the computer really doesn't have this. Next slide, please. So the next thing AI is good at is problems that have a lot of data available. And when we talk about a problem in machine learning, we're referring to a situation where we want to predict something based on some other things. So in the example we used earlier, the problem is given a satellite image to identify the locations of cars. And there's no hard and fast rule for how much data is enough to apply machine learning, but in general, algorithms will work better if you feed them with more data. So if you only have locations for 10 cars, your algorithm is probably not going to do very well. 100 will be better, 1,000 will be even better than that. And in general, you need to have data that provide you with diverse examples of the kind of thing that you'd like to be able to predict. Next slide, please. Okay, so you need to have unambiguous correct answers. So for example, you have a lot of photographs of people's faces, and you want to know whether the people in those photographs are wearing glasses. Machine learning will be a really good choice for this. The answer is pretty unambiguous, and it's easy for a person of average capabilities to check whether the computer got this right. If you want to know whether the people in these photographs are attractive, or if they look like they're angry or something like that, you're going to have a much harder time because even humans might not agree on the correct answer in those cases. Next question, or next slide, please. So sometimes you're making decisions where a person might reasonably demand to know why a certain choice was made. You can think of things like criminal sentencing or evaluating a college application. And we all know that humans can be subjective and biased, but one advantage to humans is that if you ask them what they were thinking in a particular case, they can give you some kind of coherent answer. Most machine learning algorithms can't really do this. They can't explain how they reached a certain decision. And so machine learning is a better choice when what you really care about is getting the right answer and not about how you got to that answer. Next slide, please. So the last point I want to mention is that machine learning is great when you need to make decisions very quickly about a large amount of data. So a great example of this is online advertising, where people will use machine learning to target ads to potential buyers. And it's okay if those models aren't perfectly accurate because they make a huge number of decisions, and even small improvements will add up to a significant advantage. On the other hand, if, for example, I were looking to buy a house somewhere, I wouldn't rely on machine learning so much to help me do that because it's a decision that I don't have to make very often and where the stakes for me personally are a lot higher. Next slide, please. Okay, so next I want to talk a little bit about some examples and some benefits of machine learning. Next slide, please. So the first really clear benefit in some cases is speed. So this is an example of a classification system where you're using machine learning to quickly filter and sort vast amounts of information. And this is a system that was designed to collect reports of damage or offers for help after a natural disaster. And so the algorithm's job is to direct incoming tweets to people who will be able to use the information contained in them. And this required human curators to manually label tweets according to the type of content they contain. And this labeling process can take a while, but once the algorithm is trained up, it will learn to associate certain words, phrases, or patterns with different resource needs. And so after a disaster, when this information is coming in thick and fast, you can use an algorithm like this to direct traffic and making sure it's prioritized and being sent to the right people. Next slide, please. So this is an example of how you can use artificial intelligence or machine learning to match services to people. And this is a company we did an in-depth case study on in our report. It's called the Harambee Youth Employment Accelerator. And they're a company in South Africa that helps young people who are at risk for unemployment to get their first jobs. And part of their approach is to collect data on each applicant's skills and personality and match them with a job where they're most likely to succeed. So they're exploring machine learning as a tool to get faster, more precise matches for a larger number of applicants. There's a link for a video at the bottom. We're not going to show you that video now, but after the webinar you can take a look at it and it will explain more about what Harambee is doing and how they're doing it. Next slide, please. So in the last couple of examples, the goal was to automate decisions using a computer. And sometimes we actually have a different goal. We want the computer to find patterns that will be useful for human choices. So there's researchers at the International Center for Tropical Agriculture in Colombia. And they've been working with farmers to develop machine learning models that can predict yields based on things like weather or farming techniques. And their goal isn't really to predict yields. What they want to do is to use their model to make recommendations about how farmers can improve their yields, especially under changing climate conditions. And this is a really great example of a partnership where farmers benefit from a machine learning model even without using it directly. Next slide, please. So another benefit sometimes of machine learning or AI systems is that they can reach very, very large scale. And one example of a type of system that can do this is chatbots, which are systems that are designed to analyze text inputs and respond to them with text that sounds authentic. And there are several startup companies that have launched AI-driven mental health apps that allow users to talk through depression, anxiety, or fear with a computer rather than a therapist. And one group's website says that their goal is to deliver affordable, on-demand, and quality mental wellness to everyone using psychological artificial intelligence. And in some ways, this is a really great application. Mental health services are often lacking in developing countries or in humanitarian crises. And this could be a good way of providing care to more people than have ever had access before. And some trial deployments have found that talking to a computer instead of a person removes some of the stigma that exists in some cultures around seeking mental health assistance. It can also raise some really troubling questions, though. So it's possible that these apps could inadvertently collect personal information about vulnerable people, and then what are the responsibilities of the company operating with this chatbot, and what should they do with that information? Or if someone confesses that they're planning on hurting themselves or hurting someone else, do the chatbot's operators have a responsibility to inform the authorities? And we'll probably see more examples of things like this in the future, and there's going to be some real uncertainty and ambiguity about the legal and ethical implications of these things. Next slide, please. So that brings us then to the next big topic we wanted to talk about, which is challenges and risks. Next slide. So I really love this map. So this is a map that was done a couple years ago. Distribution of the world's mappable IP addresses. And so digitally generated data are mostly coming from the areas that are red, and very little data are coming from the areas that are shaded in darker. And so for the people who live in those red areas, it's a lot easier to find out what they think and how they spend their time and what kinds of things they like to buy. And it's easy to become very informed about the people in those areas. In those darker areas, data are going to be more scarce, they're going to be more expensive, and they're going to be lower quality. And so that's a struggle that we often have in the development field, that the areas we're most interested in are the areas that it's hardest to get information about. Next slide, please. Another really persistent challenge is making this transition from a proof of concept to a really scalable product. And there's a few reasons that this can happen. And I am far from an expert in how to bring things to scale, but these are holes that we've seen people fall into. One of these is that people will solve the wrong problem sometimes. Any process has multiple steps, and you often need to choose which of those you're going to automate. And there's a tendency sometimes to automate the one that's easy to automate instead of automating the one that's the most expensive or time-consuming or error-prone. And sometimes it's actually better to make a small improvement to a really serious bottleneck than it is to make a big improvement to something that actually already works pretty well. The next thing that can happen is that you'll get mismatch with existing decision systems. So if you're designing a system to support human decision makers, you need to understand how they currently work. So you need to know what information sources they rely on, you need to know how quickly they need to make decisions, and you need to know how much power and autonomy they actually have. Because if you make recommendations that no one can implement, then you're not actually helping. The third point that I mentioned here is brittle models, and there's two different ways that models can be brittle. One of these is that they won't generalize well to a different context. So often, if a model is reapplied to a different population or in a different location, it won't be as accurate as it was before. The second point is that context is always changing with time, and models can lose accuracy as they get older. And it's often necessary to retrain models with new data to make sure that they stay accurate. And that brings us to the fourth point here, which is sustainability. Models need to be updated, maintained, and monitored to make sure they're still performing as intended. You can't just set up a bunch of servers and leave it running, and so that ongoing attention takes time, and it takes money, and it takes people to do it. And so if you're building something to hand off to another organization, you need to make sure that they have the capacity to keep it running. And then the last point here is vendor lock-in. Everybody wants to be a monopoly, and so if you rely heavily on proprietary tools and formats, there's a chance that you or the partners that you're working with could wind up stuck with technology that won't be affordable over the long run. So down at the bottom of this slide, I have a link to the principles for digital development. Those are a set of general principles around technology that have been endorsed by USAID and about 100 other development and humanitarian organizations, and they're designed to address specifically these types of problems that can come up when we're bringing these proof of concept ideas to scale. Next slide, please. So this is a different kind of problem. And I want to talk a little bit about how biased training data can lead to different types of biases and inequities. So Turkish is a really interesting language for many reasons, but one of them is that they do not have gendered pronouns, he and she. Everybody is just O. And so what we've got here is a bunch of sentences in Turkish that were typed into Google Translate. Can we go to the next slide? There we go. So when we translate these into English, we don't have this choice of remaining gender neutral. Google Translate has to pick whether the sentence is talking about a male or a female. And unfortunately, the choices that it makes match traditional gender stereotypes. Men are doctors and engineers, and women are nurses and cooks. And it isn't because somebody at Google sat down and decided that they were going to write a sexist translation algorithm. It's because Google Translate was trained on human-generated text on the internet. And the algorithm learns language from humans, and we use language in a way that has these gender biases. So this can be a really hard problem to fix, in part because it's not clear what Google's responsibility actually is. So should we be looking at them to build in some correction to even out this bias, or should we be congratulating them for their ability to mimic human language so well that they can even get our biases right? And there's no really simple answer in situations like this. Bias can come from patterns in the training data that reflect existing inequity. And so even if we don't tell it to, an algorithm will successfully learn to discriminate from our human example. Next slide, please. So as we think about how some of these biases can play out in our work, it's important to remember that machine learning systems always evaluate new data based on what they've seen in the past. And this means that they can often struggle with situations unlike those they've seen before. So for example, many employers are using algorithms to screen job applications. And what they do is train these algorithms on previous applications and on information about which applicants were particularly successful employees in the past. So imagine that a hiring process has been historically biased against women or some other group, and then the application selection algorithm will learn to reproduce the bias of past hiring managers. So When we first started talking about this, we were always introducing this as a hypothetical, but if you've been watching the news, this actually happened, that at Amazon, they developed a tool to screen applicants, and they ended up getting rid of this tool because they just could not fix the gender biases in it. It had this persistent problem, and they could not find a way to correct it. So in general, we need to question the training data that we have access to and how it might encode social inequities that we should be striving to change. And this can also tie into the organizational processes that we use when we're collecting and curating data, that our choices about what data we're going to keep and what data we're going to throw away can also lead to these kinds of blind spots further down the road. Next slide, please. So as another example, we can think about the prediction of crime. So there's a police department in a major U.S. city that has been using a machine learning algorithm to predict where crimes are likely to occur so that they can send police officers to the right neighborhood. And so if we want to build a supervised machine learning model, we need to be able to measure the thing that we want to predict. And sometimes measuring that is difficult, dangerous, expensive, or even impossible. And when that's the case, we rely on proxies. So crime is one of these things that can be really difficult to measure because many criminals are not caught. And so in this case, the police department decided that instead they were going to use arrests as a proxy for crime. And a proxy is different from the quantity we care about, but we can use it sometimes as a substitute. And so the map that you're looking at now shows the distribution of drug-related arrests in this particular city. And can we move to the next slide? There we go. And so this map on the right now is showing an estimate of where drugs are actually being used based on public health data. And so the geography of drug arrest is very, very different from the geography of drug use. And this is because arrests aren't a perfect proxy for crime. Arrests only happen when you have both crime and police officers in the same place. Neighborhoods with a heavy police presence will have a higher arrest rate, even if their crime rate is similar to elsewhere. And in the U.S., this is often true of poor and minority neighborhoods. And so an algorithm that uses drug arrests as a proxy for drug crime would end up dispatching even more officers to these heavily policed neighborhoods, which would lead to an even higher arrest rate. And so you get this runaway feedback loop where more and more resources are being concentrated in less and less space. So in short, using the wrong proxies in algorithm development can cause us to predict the wrong thing. And in this example, that can lead to unfair targeting that can reinforce existing inequities. Next slide, please. So after all that heavy stuff, I wanted to end on something that's a little lighter. So it's a really cool application where you can feed it an image and it will come up with a caption for this image. And this is a great way of showcasing both how good these systems have gotten and also how far they have left to go. So the one on the left, it's calling this a woman riding a horse on a dirt road. There is certainly a dirt road and a horse, but the computer is missing on what most humans would find to be the most interesting thing about this picture, which is the person being dragged on the ground behind the horse. In the second image, it says it's an airplane parked on a tarmac at an airport. You have an airplane, but it is certainly not parked. This plane looks like it's about to crash. And so there's sort of a story behind this image that the computer isn't really grasping. And in the third one, it's calling this a group of people standing on top of a beach. And again, there's people there and there's a beach there, but what's really happening is that these people are fleeing for their lives because their house is sinking into the ocean. And so again, there's an emotional content to this and there's a story to this that the computer isn't necessarily picking up on at this stage. The next slide, please. So for this last section, I want to get practical. And I want to talk a little bit about what we and our organizations can do to help shape the development of AI. Next slide, please. So in our report, we make a bunch of recommendations, but we boil these down into 4 really big high-level recommendations. And the first one is that we need to be the advocates for our problems. There's a tendency sometimes to let the silver bullet technical solution be the thing that everyone's focusing on, and we need to be the people who are rooting for our problems and keeping people focused on the problem. And so this means that we think of things like the suitability of machine learning for the problem we're actually trying to solve and whether the problem is a good fit for machine learning. We need to be asking whether we're trying to predict something that's objective and easily measured. We need to be asking whether we have access to the right data to be able to do this, or how good our proxies are. And probably the most important thing is to think about how the problem is currently being addressed and what the status quo is, and how the introduction of machine learning will change that status quo for better or for worse. Next slide, please. So the second big recommendation is that we need to work with other people. We need to work with technologists and researchers, and it's especially important that we try to leverage local expertise. When possible, it's great if we can rely on local machine learning experts to develop tools themselves, because they'll have a lot of that context sensitivity. And even when that's not feasible, we can help make those connections between the software developers and the local subject matter and context experts, so that those people who know the background and know what's going to work are part of the process as data are being selected, as models are being built, and as tools are being integrated into practice. And we also need to think about what feedback processes might look like so that we can incorporate local testing or local validation of models. Next slide, please. So the third thing that's important is to speak up for context. So people who are working in the development or the humanitarian or the conservation space are going to be steeped in the context of the challenges they're trying to address to a greater extent probably than the people who are building machine learning tools with them. And so you need to make sure that you're bringing that perspective into the mix. Again, things like thinking about whether your proxies are appropriate. One example is that in some places, if you're looking for a proxy for household wealth, taxable income might be a really great proxy for that. If you're working somewhere with a large informal sector, that's going to be a terrible proxy. And it's really the people who are closest to the ground and closest to the problems who are going to know that kind of contextual information. Next slide, please. Okay, so one thing that's important to keep in mind is that machine learning is really, in some ways, not that different from other technologies. And we need to be thinking about how the use of these tools is going to affect the end users. So we need to be proactive about questioning how a machine learning model will perform for different groups of people. Does it fail more often for some populations than for others? And what are the consequences when it does fail, and who ends up being harmed? And I think one thing that's really important to think about, especially when you're in a context where there's a lot of things going on that can be complicated, is that to think about things in terms of power and in terms of political economy, and understanding when a tool is going to change the distribution of power between different people or different groups of people. So we all have a responsibility to make sure that those kinds of questions are being considered as we embrace the potential that's offered by machine learning. Next slide, please. So this is our report that Layla mentioned at the beginning. And we try to do a few different things here. One of these is to highlight some use cases of machine learning in international development and really talk about some organizations that are getting things right, in addition to exploring some of these risks. We talk about some of the real fundamental issues and go into a bit more technical depth than we've been able to in this webinar. And we offer some guidance on how to mitigate harms and establish safeguards as we explore the use of artificial intelligence and machine learning technologies. And so if we can go to the next slide. Though I guess this slide is really just the wrap-up. please take a look at our report. Definitely, I hope a lot of you are able to attend the NetHope Summit events that are happening next month around artificial intelligence, and I'm hoping that we can get more people who are involved in the NetHope community engaged with these kinds of issues and helping to shape the development of these technologies in a way that will be responsible and that will help lead to improvement in the issues that we all care about. And so with that, I'm ready for questions.
Great, thank you very much, Craig. I hope this provides a good or baseline understanding of the artificial intelligence and machine learning tools and the benefits for our sector and beyond. And as Craig mentioned, we will continue the discussion not only through this Q&A, so I encourage you to continue posting your questions in the chat window, but especially at the summit where we'll be sharing a lot more use cases and discussing some of these topics in a lot more detail, including bias and the role of humanitarian sector, as well as how we best can work with the technologists and the researchers. So I'll kick us off with the first question, and Frederick and I will alternate. Do continue posting the questions in the chat window. So the first question, just taking a step back and really looking at some of the risks and recognizing both the benefits but also the challenges that are involved when incorporating such advanced technologies in our work is around, should we be early adopters or wait? Should humanitarian agencies be early adopters of AI? And if yes, what are some of the necessary conditions for incorporating AI and machine learning tools into our work well?
Yeah, that's a really profound question, right? It gets to your overall stance toward technology, and there's not a simple answer to that. I tend to think of that in a couple of different ways. One is that being an early adopter has some risk associated with it because we're doing things that are really important and really high stakes, and we don't want to get it wrong. And so, the agency where I work, people often tend to be somewhat risk averse about technology, and that's probably justifiable. Because, moving fast and breaking things is not where we want to be. We're the people who are in the business of trying to keep things from getting broken. At the same time, there are a lot of things that just don't work very well. And so to the extent that we can use technology to make them work better, we should. And so I guess what I would encourage is not to be an uncritical early adopter who's always chasing after the newest thing, but also not to be an uncritical technology hater who just insists on doing everything the way that we always have. What we need to do is really ask those probing questions about whether a new technology is really the right choice for the thing that we're trying to do. I think the other thing to keep in mind is that experimentation is a good thing, especially when experiments are designed well and when experiments are small and controlled. We don't want to bet the farm on a new technology in the rollout of something really huge and critical. It's much better to do things, at least initially, in terms of a small-scale pilot where we can evaluate the results of that and learn from them, and then transition to things that are better integrated as we develop more evidence about what a given technology solution does and doesn't do well.
Well, thank you, Craig. There's another question that's somewhat related to, maybe a good follow-up question to what you just addressed. The question is, I imagine humanitarian agencies would tend to outsource development of AI projects rather than have the skills or the capacity to do so in-house. How would they best work with partner organizations to avoid some of the pitfalls you mentioned?
Yeah, so that is really a major focus of our report, because in talking to our colleagues who've been working with this technology in various ways, what we often see is these sort of partnerships. It might be the kind of thing you're describing, where you'll have a humanitarian organization working with a company or working with another organization that does bring the technology skills into the mix. Sometimes it's even sort of two teams within the same organization who are collaborating together. But usually you have some kind of partnership where you have people who are the subject matter experts, who are sort of the owners of the problem, and then you have, for lack of a better term, the technology people who are trying to bring a specific solution to bear on that. And so that is definitely the scenario that we're picturing and that we discuss at length in our report. But I think those 4 points that I brought up toward the end of the presentation are really key there. I think for the people who are on the subject matter expert of that side of that, it's important to be informed about what's going on. And I think the one thing that I didn't mention that I think is really important is to insist on your right to understand things. So I really dislike when people will introduce themselves in a meeting or in a conversation by saying, well, I'm not a technical person. And I feel like grabbing them by the shoulders and shaking them and saying, of course you're a technical person. You've been working in agriculture or in health or whatever it is you do for decades. You know this subject matter material inside out. Just because you don't know how to code doesn't mean you don't have something important to bring to this conversation.
Craig, also very much highlighting this kind of important part of knowing what questions to ask, not necessarily being an expert in the problems that we need to solve, but knowing also what questions to ask as you become, as you start incorporating AI into, or any other tool into your work. Just to follow up on this question, because there's been a bit of discussion around there is experimentation, and when you experiment, you might start actually by working, let's say, with a research institution or with a certain technology vendor. But there's also the big difference between experimentation and productization and scale. So really benefiting from that initial investment. So can you say more on that and what we learned so far?
So again, productization is not something that I'm really an expert in, and so I don't want to go too far beyond what I know here. But I think it's important, and again, coming back to the digital principles, which I think are a really great resource on this, that even at the level when you're designing an experiment, it's generally not good to design an experiment or a trial that is incapable of being scaled, where you haven't thought about what a pathway to scale might look like or what sustainability might look like. That often you get things that were supposed to be a pilot that end up sticking around much longer than that because people found them useful. And in one way that's a sign of success, but it can also set you up for problems if things that were intended to be temporary wind up becoming permanent instead. And so I think I would definitely recommend the digital principles as a resource to turn to at least begin structuring those conversations before you even begin an experiment or a pilot about, if this succeeds, how are we going to roll forward with it and how do we set ourselves up to do that from the outset?
Yeah, thank you, Craig. And this is a complex question, and we'll be actually more time on this specific question at the summit. This question from one of our participants, first some context. Oftentimes we see a question from UN actors that companies and organizations make their algorithms open source. When, as you have described, this process is often timely and costly. Is there a common ground here?
So, okay, now I'm understanding the question. Yeah, that's hard. I think one just macro level development in the software world right now is that you have companies that are building proprietary offerings on top of an open source stack. So if you think in the big data world, for example, you have tools like Hadoop that are used very broadly, and that it's it's an open source tool at its core, but you have different companies that have productized this in different ways by building a nice user interface or building other features on top of this open source skeleton. And I think that's the kind of thing that's worth encouraging, because it can lower barriers to entry for new companies coming in, it can increase competition, it can lead to better products. And I don't think we want to be dogmatic about saying things always need to be open source, because there are times when proprietary software solutions may in fact be a better way to go. I think and it'll change a company's business model when they start open sourcing all of their software. Then their advantage comes from moving really quickly rather than from having secret sauce that no one else can understand. And so, yeah, I feel like my answer to every question is sort of, it depends, and that's why I work at USAID. But I think you don't want to place an undue burden on people you're working with, but at the same time, you don't want to make it impossible for tools to be sustainable or for other people to get into the mix. And so I think that's a conversation that's worth having with people, and being open-minded about both the open source and the proprietary sides of it.
Yeah, no, thank you. And we also invite everyone else to, if you have specific examples of how you've gone about doing that, please do share that with us. Frederick, what's our next question?
I think we have time for one more question here. There's a commentary also. I appreciate your points on identifying problems and the explicit issues associated with a given problem. Are there programs and procedures in place within the humanitarian system to express these issues to companies and organizations that are developing machine learning technology? So this is obviously a longer discussion we have time for today, but it's also a question we can address also in more detail once we get to the NetHope Summit. There we have
totally
Google, Microsoft, and IBM.
Was the plant. Oh, sorry.
Go ahead if you want to address it.
Oh, I love this question, and I would love to have a more extensive discussion around that. I do not have all of the answers, but that's totally the direction that my team is thinking in that, okay, now we have this body of research. What is the next step in trying to create processes and institutional structures that will help people come together who are interested in improving the ways that things work and give them a framework to operate within? And so I am so excited that this is something that's on the table, and it's something that's going to be discussed at the NetHope Summit.
Great. Thank you so much, Craig. Thank you all for joining us and for excellent questions, and Craig for excellent presentation, as one of the participants noted. As a reminder, we will continue this discussion at NetHope Summit. We have a plenary, a breakout session, and a whole workshop. And based also on your input, we will continue to curate future webinars and engagements so we can learn from each other. Frederick, over to you to wrap up the webinar.
Thank you very much, and thank you, Craig, for making a super complicated topic something relatively easy to digest. It doesn't make it any easier, but you provided some great understanding today, and hopefully prepared everyone for further discussion. We're very, very excited about being able to do this more justice at the summit, and be able to talk to some of the large players in the industry there as well. So for those of you that are going to join us in Dublin in a couple of weeks, get prepared for healthy discussion there. And for those of you not going to be there, reach out to Leila and Craig and the rest of us to continue the discussion well beyond the NetHope Summit. So with that, thank you very much to Craig again. Thanks for Leila for producing this no loss generation tech talk, this webinar series, so appreciate that. And it only remains for me to say thank you very much to all the attendees and the great interaction. Enjoy the rest of your day and keep an eye on the event listing on the NetHope Solutions Center for further webinars down the path.
All right.
Take care, everyone.
Thanks so much, Frederick.
Bye-bye.
Bye.
Thank you.